Why did the UAHM family of hypotheses come after the PBS? We have already seen that the PBS family of hypotheses have early roots in the history of biology, driven by the early suggestion of Darwin in his letter to Hooker in 1871, and the subsequent publication of the Miller-Urey experiment and the structure of DNA in 1953. Discovery of the genetic code, combined with Darwinian principles such as the replicator concept popularized by Dawkins, also played an important role in framing discussions concerning the origin of life in terms of templates, replication, and natural selection ever since. The UAHM hypotheses did not begin to take shape in the scientific literature until 1988, however, long after discussions of abiogenesis had already been framed in terms of the PBS, replication, the genetic code, and natural selection. In terms of the geology of UAHM, rocks of volcanic origin that have especially high content of metals such as iron and magnesium, called ultramafic rocks, become hydrated to become rocks known as serpentinite in a process known as serpentinization. Serpentinization, a review by Judith Moody, appeared in the peer-reviewed literature in 1976, and UAHM were not predicted until the 1980s. This later discovery all but guaranteed that UAHM hypotheses would have to compete with a firmly entrenched PBS school. Consequently, even though the peer-reviewed arguments are now more favorable for UAHM, these are still largely absent from textbook discussions concerning the origin of life. If it were not for Nick Lane's 2015 publication of The Vital Question, this topic would be largely off the radar for non-scientists, despite the fact that some popular articles have appeared over the years and could easily be found with a Google search. Searches, after all, do require a searcher who has a good reason to take the time to enter particular keywords.